these are both 2-ton heat pumps. And initially I had two just like that smaller one. The one on the right is a 10 SEER, the one on the left is a 17 SEER two-stage. This is the latest in heat pump technology. It has a separate dehumidifier, which is great in this climate. Two-stage heat pump. It's got a two-stage compressor, so it doesn't have to come on full blast every time the thermostat kicks in. The other one is the older style that does. So that difference cut my heating and cooling energy use by roughly 40%, going from a 10 SEER to a 17 SEER.
Wow.
The payback is fairly lengthy, but you know, if you take care of it, it's going to last easily 15 years, I hope. The older one lasted 15 years and it was still kicking.
That's exactly what we're going to do in our business spotlight. We contacted several contractors in the Portland area to see just exactly what's going on with residential geothermal systems. What we found was that there are a lot of new installations happening all over. So to show you exactly what a ground source geothermal system looks like, we go out to the field with Tom Hopkins.
Well, thanks, Sherry. I'm usually not in front of the camera. I'm normally behind, but today I'm going to step out here and show you what's going on with geothermal. I'm here with Brian Erdahl from Jacobs Heating and Cooling. They're in the middle of installing a new system up in Sylvan Hill. Brian, thanks for joining us.
Not a problem. My
Tell
pleasure.
us, what's happening back here?
Well, what we have here is a drill rig that's going to be putting in a 150-foot ground loop. What we got is an older home built in about 1940. He's actually doing upgrades. He's doing insulation upgrade. He's got a furnace on the lower floor and a furnace on the upper floor. He has a total of 850-foot boreholes on this particular project, and what we're going to do is basically link 4 loops up to the lower system and 4 loops up to the upper system. We'll split it up that way.
How big is this hole that they're drilling here?
This particular project is actually a 3-inch borehole. We're doing 2 3/4-inch feeds down the hole for a total of 150 feet. We have 1,200 feet of bore total. We're actually looking at about 2,400 feet of pipe on this project. Basically what we need is enough thermal mass in the ground to basically handle the amount of load of the house. So what we don't want to happen is end up having 100% run times on these systems and freezing the ground.
How do you determine how deep?
What we usually do is we have our outfit here, Geodyne, we work with. They look at surrounding areas of old well log reports and kind of determine what we're going to hit at what depth, and to kind of base everything on that. So here what we're actually drilling into is a clay type soil, and anything past 150 we're going to hit basically solid basalt. I originally wanted 200s. We determined 150s to save the homeowner quite a bit of money.
What's the temperature at 150 feet?
In our area, our mean earth temperature is between 53 to 55. It may be a little bit warmer when we get down to the 150-foot depth, but not much. That's what makes these systems so efficient, is you're working with a stable temperature of the ground. So it, unlike an air source where it's the air that's determining how much BTU you're getting out of the system, these geothermal systems are working with a stable temperature, so they get all their BTUs all the time. It doesn't matter on if it's -20 outside or 120 outside.
Yeah, it always struck me as funny on an air-to-air system that you're trying to extract heat out of cold air.
Yeah, and that's exactly the point. It's a pretty simple concept. It's been around since the 1940s, but people are finally looking at it as a good sustainable way to heat their house and save a lot of money on their energy bills.
We're here with Al Jubitz. He's the homeowner installing the system, and the first question I have for you, Al, is why are you doing this?
You know, I'm really excited about this technology. Its efficiency rating is so much better than what I've got. Furnaces are 96% efficient. This is 400% efficient. I can get off fossil fuels in this house. The electric bill will go up, but the way I figure that is that electricity is renewable. Wind and solar.
So I assume you're on the PGE all-wind program?
Yes.
Okay. I understand that there's an added bonus to this besides just heating and cooling your house.
Well, the hot water, that's a bonus. You know, a lot of the gas bill goes to heat hot water, and I've looked at tankless hot water heaters and I like those. But this byproduct of this heating or cooling system is hot water, so that's another benefit.
It's pretty commonly known that these systems cost a little bit more than your air-to-air or your gas furnace. How long do you expect it'll take to recover your investment?
I think it's about 14 years
14
with the
years.
incentives and with the power saving. Don't hold me to that, but it's close enough to make me want to do it. This stuff is for real. It really works.
So Brian, we're looking at the pipe that's going to go in this hole. Unfortunately, they hit some rock back there, so it's not going to go in today, and we're going to miss that. But tell us a little bit about this pipe. This isn't your average PVC, is it?
Well, not exactly. This particular pipe is a HDPE poly pipe. The HDPE stands for a high-density polyethylene pipe. It's designed to withstand the expansion and contraction of the pipe between the heating and cooling season.
In the heating mode, we're constantly extracting heat from the ground, so our loop temperatures can see 32 degrees. So at that point, we need a type of antifreeze to make it to where the water doesn't freeze. And so as we're extracting that heat out of the ground, we're running that through our refrigerant to water exchanger. So what happens is we extract all the heat out. As we're extracting, the water gets cooler as we're putting it back into the ground. And same with heating. We can get up to 90-degree water temperatures in the cooling mode, because at that point we're rejecting the heat back into the ground.
As you can see, we actually have a U-bend already on the end of the pipe, and this particular length here is already measured out in a 200-foot length to go down in the borehole. So they know that the pipe has actually hit the bottom of our bore after they're done drilling.
We're not going to see it going in the ground. We're going to have to imagine that. Right now, we're going to go to a new house that's under construction and take a look at the mechanical side.
That sounds great.
Thanks a lot for showing us
Not a
your
problem. My
project.
pleasure.
Well, we're here with Norm Matthias from Specialty Heating and Cooling. We've taken a slight detour on our way to the new construction site to take a look at the, well, tell me what it is.
Well, it's a geothermal system with a horizontal trenching. So we've got a loop field being installed for this gentleman's home that is has about 2,400 feet of coiled pipe in the ground. And the ditches, each ditch will carry 1 ton of cooling or heating for the home on his heat pump system. We dig it with a track hoe, and so all of the work will take place in his side yard here and then be recovered again and backfilled and then reseeded. So by next summer it'll look pretty much like it did in the beginning.
About how many feet are you going down, and why is that significant?
Yeah, we just go down 5 feet, and 5 feet, one thing, that's as far as we can go legal without shoring. For, you know, OSHA standards, we can't go below 5 feet. And it also, at that depth, the earth will maintain a temperature of about 50 degrees year-round. Even though we take and remove some heat and put heat back in the ground with our loop field, the earth has enough time at that depth to regenerate with the mass of the earth and the lengths of pipe we put in.
Well, we just looked at a vertical bore. We've got a guy going down 150 feet with 8 wells, and that seems a little more complicated. Is this the preferred method if you've got the space?
Well, it's less expensive to do this. Well drilling does cost more to do it. It's just as efficient to go down. They don't have to use as much pipe. Once you get that far into the earth, the regeneration process is a little more, more quicker. So we've done homes with the vertical boring many times. In a residential application, they may have a small side yard alongside the driveway where they can punch holes and put in a 4-ton loop field in an area that's only 20 feet by 20 feet. So we started doing this in about 1990, and for several years there were good tax credits incentives, and we installed dozens of these at that time. And then as the tax credits incentives kind of faded away, so did the work in some respects. But now, however, with the new tax incentives, it has generated a lot more interest. But it's a 30% federal tax credit on the installation. So on the entire installation of this product, you're going to have the loop field, electrical connections, everything that makes up the entire package does qualify for the 30% tax credit.
Guy Lewis, you're the owner of this property, and it looks like they made quite a job of your yard here.
They've done quite a job. They started yesterday morning and ended up, well, they're still working. They've got a ways to go, but there's going to be a lot of dirt moved.
Can I ask what your heating bill is now?
The last time we ran heat on the whole house, it runs about $350 a month. Right now we don't heat the upstairs part of the house, and we do heat the downstairs with a pellet stove. And the electric furnace heat beyond that. So I'm hoping for to be able to, first of all, turn the heat back on.
Right.
And with the heat back on, I would hope that it comes in something like 150, maybe 200.
All right. So you guys get one on the end, one on the other, do a little tug of war. That's not going anywhere.
No, that'll be stronger than the pipe itself right there.
Here we are inside a new construction that's going on in the Portland area. I'm with Greg Bergeron, who's with
Geonomic Development.
Geonomic Development. We have an interesting system in this house, so you want to tell us a little bit about what this does?
Sure. Let's start with over here. We have a radiant floor system. We heat the floor through individual zone controls so that the customer can keep rooms warm individually. We also have forced air in the home, heating and cooling. The unit does all in one piece. We also in the forced air have similar zones also, so the customer can control his heating and cooling through the forced air end as well as the radiant floor. The context of the heating system is made by geothermal heat. We actually extract heat from the ground, amplify it through the refrigeration process, and heat the water in this tank here, which heats the radiant floor. We have the compressor that starts most of the process. It essentially allows the system to run at one operating pressure and temperature, and then a higher one according to the home's needs. In the back there is two heat exchangers. The back one is the ground loop. The one in front is the hot water loop. And then the gray one you see back there is the domestic hot water system. This is the refrigeration coil that either heats or cools by forced air in the home. This is an electronically controlled motor. It actually is self-adjusting to the speed of the compressor. There's a microprocessor in the end of the shaft that measures what it's building, so if the customer doesn't change his filter on time, which is common, it will just ramp up the speed in order to take care of the flow of air in the home.
Okay, here we are in the great room, the largest room in the house. If we pan up, we can look through the ceiling rafters that aren't quite finished yet to a white box that's up there near the roof. What's that about, Greg?
That's a Honeywell air-to-air heat exchanger, and what that does is it takes stale air from the house, exhausting it outside, bringing fresh air in across the heat exchanger, obviously, and saving 80% of the energy you normally would waste out your bath fans.
Fantastic. Well, it looks like we've got a really super efficient heating system in this house, state of the art.
Best you could get.
All right, Greg, thank you so much for showing us around. Appreciate it.
Thank you.
I'm Tom Hopkins, bringing you the tools to be sustainable today.